All right, for this section, we are going to be talking a little bit about quadratic formula or quadratic equation graphs. A couple sections ago in chapter 9, we were doing a lot of stuff with, multiplying binomials, and they had all these x squareds and things like that. Well, those can be displayed also in the form of graphs, and that's what we're going to be talking about in this chapter. How to graph them, what the graphs look like, why they look that way. So there's some formulas and some things in there that we're going to cover. There's also a graphing calculator I'm going to show you, which makes life a lot easier, but oftentimes you're going to have to be able to do it mathematically. So that's kind of what the gist of this section is about. So kind of going through, if you go on my website and look at the green book in chapter 10, this is the notes that follow that. So I'm just going to go through these, follow along as we go, and there's a couple sample problems for this section. All right, a quadratic function is a function in which the highest degree of any term is 2. So basically your x squareds are what make up quadratic functions. So we've seen them like ax squared plus bx plus c. You've seen that form before in chapter 9. So that would be a quadratic function. The simplest form of a quadratic function is y equals x squared or something equals x squared. So just this part basically. That's going to be known as the quadratic parent function. A lot of times when we're talking about what the graph looks like, whether it opens up, down, narrow, skinny, we're comparing it to this quadratic parent function, which you see down here. All right, the graph of a quadratic function is a U-shaped graph, and you'll hear me referring to this. It's called a parabola. All right, so anytime we talk about a parabola, we are talking about just the shape of a graph. They can open up or down or whatever, but this parent graph looks like this. All right, so those are known as parabolas. All right, so properties of parabolas. You can fold a parabola so that the two sides match exactly. All right, this property is called symmetry. All right, the fold or line that divides a parabola into two matching halves is what we're going to refer to as the axis of symmetry. A-X-I-S. All right, so the axis of symmetry basically makes a mirror image. So if you can see how this parabola goes right here, this line right here, if we fold it in half, this dot is mirrored over here. This is mirrored over here. All right. So in this graph, this is basically the same graph we see, the axis of symmetry is the y-axis. So I drew it up here. You can see it there. It's not always going to be the y-axis, but in the parent function where it's just y equals x squared or y equals ax squared plus c, meaning there's no x term, the axis of symmetry will be that y-axis. So you can see that here. All right, so there's always going to be a parabola. We can fold over an imaginary line called the axis of symmetry, which will divide that graph in half. All right, next page. Okay, so also within graphs, and again, we're just kind of covering the basis of what these parabolas do. There is a high or a low point of the graph, and this is called the vertex. It's basically where that graph, the lowest point of the graph or the highest point of the graph. All right. There's a couple things in here where it talks about whether the graph opens up or opens down. All right. So basically, if a is greater than 0, meaning this is a positive, so a positive something x squared, blah, 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 it's going to be opening up like this. And if a is less than 0, meaning it's a negative number, so this would be like y equals negative ax squared plus bx plus c, then the graph is going to be opening downwards. So there's things we can notice about with a graph of whether it opens up or down. It's going to tell us whether this a is positive or the A is negative. So right away you can kind of see that within the graphs. All right, some more terminology to cover for this portion is we also have a name for the lowest point and the highest point of the graph. So if the graph has a lowest point, meaning the vertex, which would be here, and here's a vertex where it would be the highest point. So if it is the low point of the graph, we say that the vertex is a minimum. So this has a low point of the graph, and if it is at the high point, meaning the graph is opening down so that the vertex is the highest point of the graph, that's a maximum. All right, so you can always say, sometimes one of the questions might say, does a graph have a maximum or a minimum? And you can say, oh, it's at the low point, so you would say it's a minimum, or it's at the high point, it's a maximum. And what is the vertex of these graphs? And you could actually point it out based on the x and y coordinate. So here's a couple examples of what you might see for some of the problems. These two say identify the vertex of each graph and tell whether it's a minimum or a maximum. So if you can see on this graph, this point right here, and you can see the lines kind of got blocked out a little bit, but here would be the vertex, the top part of that, and because it's a top, that would be the maximum of that graph. So we know this is a max for the vertex, or for the telling whether it's a minimum or a maximum. And the actual vertex we are going to represent as an x and y ordered pair. So if you look at this is kind of, again, these lines didn't come through. This one is here. This is where 2 is. So if we look at what the value of x is in this one, it's 4. And if we look at what the value of y is, we go up 1, 2, 3. So that'd be 3. So the vertex in this particular problem will be 4, 3. We look at this other example over here, and we're going to figure out, hey, what is the vertex here? Well, I can put a dot right in that part. You can see that's the low part of the graph, so that's a minimum. And we have the vertex of the x value, which will be 1 to -3 for our x value. And our y value would be -1, -2, -3 as well. So being able to identify the vertex in a graph and telling whether it's a maximum or minimum would be part of the first part of the assignment for this chapter. Okay, the next part in this chapter, and we're going to break this up into 2 parts, is comparing the widths. So, whether a graph is narrow or whether a graph opens up wider. So this would be, 2 graphs, one's narrow, one's wide, and how do we do that? So in the form y equals ax, meaning there's no plus, minus, whatever, but in general, your a, whether it's a bigger number or a smaller number, will determine how wide the graph would be when we graph them. All right, so in this case, the bigger your a, and you'll see these absolute values, because if there's a negative here, so y equals -ax squared or y equals ax squared, this doesn't necessarily matter with the width, but the negative means it opens down and a positive means it opens up. So that's what the negative out front indicates direction. So when we talk about whether the bigger, and why I put it in quotations, because it doesn't really matter whether it's negative or positive. Just that will determine or help us identify the width. So the bigger the number is for a, the narrower the graph is going to be. So narrower meaning it's going to be skinnier, it's going to climb faster. And the smaller the value of a, the wider it's going to be. So if you're comparing numbers, you can tell whether, based on a's, whether it's going to be narrower or wider based on those numbers. So again, the negative out front, so this example right here is we're ordering them in order from your widest to narrowest. The negative just tells direction, so it can be still wider even though it's opening a different direction. So don't worry about that. Again, look at kind of like the absolute value of your a. So in this case, I have 3 graphs, y equals x squared, y equals 1/2 x squared, and y equals -2x squared. So in all these cases, these are my a's, right? My a here would be a 1. So if I'm going from widest to narrowest, all right, the biggest number is going to be our narrowest, the lowest number is going to be our widest. So if I'm looking at which of these is my lowest number, because I'm ordering from widest, meaning smallest, smaller number, to narrow, which is a bigger number, I can separate them or put them in order that way. So if I look at these, my smallest or my widest would be 1/2, because 1/2 is smaller than 1, and the absolute value -2, which is 2. So y equals 1/2x squared would be my widest. My next one would be, so I'm basically going from least to greatest, would be the 1, because that's smaller than the +2. But again, remember, absolute value. We're just looking at the value of a. So my next narrowest would be y equals x squared. And then my narrowest of these three would be y equals -2x squared. All right, so there is a calculator that we can use to graph, so you can actually visually see this, and I'm going to bring that up right now. It's on the website. It's called Desmos. So this is a good website to put in to compare graphs. So I'm going to type in those three. So I have y equals, let's see, x squared was one of them. So I could raise this to the power of 2. The other one was y equals 1/2 x squared. So y equals 1/2. And then I'm going to square that. Oops, I forgot that x in there. So 1/2 x squared. And the third one was y equals -2x squared. And you'll see that that opens downward. Y equals -2x, and square that. So you can see here when we're looking at these, you know, here's my standard form of y equals x squared. Here was y equals 1/2 x squared. You can see how it's wider. It's hard to see this one because it is opening down, but if I did it with a positive, you can see where it is narrower than that x squared. So for this first section, really just being able to identify the vertex, and on here you can see the vertex is always going to be 0, 0 for these types of problems. Identify the vertex and be able to, based on your value of a, let me know which ones are wider or narrower and be able to put those in order. So that would be the first part of this section that we wanted to cover.